Hi, thank you for attending Financial Services Cloud Symposium. My name is Mojgan Ahmadi. I am a solutions architect with Amazon Web Services. I am part of Global Financial Services team. In today's session, we're gonna go through how to define your data lake vision and roadmap and how to use that to achieve a harmonized and reliable data lake implementation. Financial institutions should have in place a strong data governance framework. This framework should have a sponsorship from senior management. Therefore, the first step is to identify organizations that are actively involved in creation of a trusted data lake. They usually are data governance, data architecture, and IT infrastructure. Once you identify those, the next step is to clarify service level standards and policies on overall data integrity, data lake risk management, and its controls. Using that, you can finalize your high level data principles. And these principles are going to help you to achieve a well architected data lake. I have put 6 principles. They are accountability, accuracy, quality, lineage, operation excellence, and security. For today's sessions, we're going to go through the first 4. Our session is limited to 30 minutes, but I wanted to give you the full list. Of course, these principles are subject to change, and they have to be set based on the type of organization, your data policy, the type of data lake you're building, and your consumers. Also, setting up data principles doesn't mean that you have to mitigate and plan all of them before you can release your first phase of data lake. What it means is you have a clear path into achieving them throughout your timeline, and they are part of your roadmap. So let's put it all together. How to drive vision and roadmap. The first step, you have to identify teams that are actively involved. Second step, identify and clarify your data lake policy, control, and risks. Using that, you can drive your data principles. And using your data principles, you can set a roadmap. By doing that, you have a clear vision and roadmap to your data lake implementation. Let's look at the first one, accountability. Accountability starts with data governance. Data governance has a very important role in driving this data principle. In order to accomplish clarity and accountability, several items have to be discussed, identified, and finalized. The first one is to identify your data lifecycle and stages. Data lakes and big data platforms gave us amazing technical ability to bring large volume of data with different kind of file formats from XML to JSON to CSV to OLTP extracts. They can handle anything. Also, they will allow you to be very flexible in terms of your schemas and how you process them. All that has contributed to some of the data lakes to become uneasy and unfriendly to use. So in order to tackle that, make sure that you identify your data lifecycle and stages. Once you identify that, go and classify type of the data you want to bring to your data lake. It can be, your data lake can be product-based, your classification can be channel-based, it can have reference data versus transaction data. Does it have sensitive data versus none, or all above? You have to classify all the data that comes to your data lake. Once you have your data's lifecycle and stages clarified and your classification is done, then you can assign data owners. The last one is to use unified naming standards and terminologies. Make sure your terminology terms are very simple, they are easy to understand, they are clear, and they are business centric. We have to all understand that the data belongs to business. They produce the data, they extract the data, they give us mapping logics, they use the data, they consume the data, they are the recipients of its data quality reports, and they mitigate those data quality items. Therefore, the naming standards should be business centric and should be easy to understand. In our example, let's say that, for example, data governance came back and told us that the data has, in this data lake, has 3 stages, and it goes through a life cycle within these 3 stages. And they want to call it bronze, silver, gold. Without going any further in this presentation, by looking at the naming that I put on the table on the screen, you can kind of guess where the data goes, where the source data goes, where the consumer consumption data goes, and probably there is something in the middle that help the data to transform to a more friendly format. Once you have easy to use terminologies, it would be amazingly easy to communicate across your lines of business and for people to understand where each data is. Business glossary plays a big role. Let's say the data governance in this example came with these 3 stages and life cycle. What happens next is data architecture gets involved. And they will go through putting some best practices per stage. On the bronze, they might say that bronze always represents the source system. It should have free file format. It should always represent the source system's file format. They might also assign an owner to it and an SLA. And they might say, as part of best practice, we would not bring any file that doesn't have a business owner and doesn't have a SLA communicated by that business owner. Also, they might ask for a file level verification. This is different from data quality verification. This is where a data architecture put a system in place in order to answer questions like, how do you know you got the right file in? How do you know this file is not a duplication of previous day's file? The file level verification has to be owned by business user, regardless of if they can, from a technical point of view, drive it or not, but they have to be the owner and they have to approve it. On the gold here, we have single source of truth. And on the middle layer, they might decide to put practices like unifying file formats. For example, all the files should be changed to Parquet. They might also, very important for financial institutions, especially if this data lake is producing financial numbers, to make sure that it's very clear what the data represents. Is it as of day, as of week? Is it monthly? It's quarterly, has to be completely clarified. Also, any file that comes in silver has to already met the SLA and file level verification that was enforced on bronze. So let's look at some patterns. Example, in this pattern, data governance came and they said that they like to have a data lake that is product-based. In that case, the architecture might decide to create a data lake that has a product architecture, which can translate to 2 separate data lakes. One of them can keep loan, one of them can keep credit card. The other pattern is that data governance can say, we like to have a risk data lake where we can do all of our enterprise-wide risk calculation. However, we like to trace that risk number back to its origination products. In that case, data architecture might decide to split the bronze and silver across different products, but introduce a gold zone across the enterprise. Again, as you can see, the direction comes from data governance because they understand the consumption of the data lake, but there the physical implementation is being done by data architecture. Let's look at our risk architecture example. If that's the architecture, how would the roles define? In this case, data governance should come and identify that there is a chief financial officer and chief risk officer are involved in this architecture because they are running regulatory reporting, risk aggregation, downstream regulatory feeds, or maybe even financial filing. Also, they identify that line of business should be involved because they will provide origination and servicing data. And Chief Data Officer's office might be involved to provide that enterprise-wide data governance. Majority of large financial institutions have a Chief Data Officer. If you do not have one in your organization, there must be an enterprise-wide data governance body to get involved. Let's look at each roles and ownerships. In this case, starting from left, on bronze zone is owned by line of business. They identify data stewards. They provide file verification requirements. They provide SLA. They provide notification requirement. Data architecture should know if the SLA is not met, who to send the notification to. Also, they produce data extract and they make sure that they add that data extract to the scope of their sourcing application. Data extract that go to data lake should not be part of data lake. They should be part of the sourcing application. Therefore, when your source application goes through enhancement, changes, replatforming, re-architecture, as part of their scope of change and change management, all their downstream data feeds are included. Also, they have to identify critical data fields because data lake can be recipients of thousands of fields, and a lot of them might be informational only. So there must be a clear identification on those fields that are critical to the downstream risk management reporting. Going to the goal definitely belongs to CFO office. CFO should give us a canonical model. They should provide us with a risk logical model. They should be the owner of that model. They should also identify critical data elements within that model. They might ask for a lot of fields, but not all of them are critical or have highest priority. They also should provide us a notification requirement per each group of data elements. And also they should register business metadata glossary on their model. CDO office has a very important role, and that's the office that drives the data governance. They are data advocates. They act like data success managers. They coordinate priorities. They can work with different lines of business, and based on what has the highest priority, they can set a priority list for data architecture. And then also they are the governing body across a line of business, CFO office, and DA. And they provide enterprise-wide status reporting and timeline. That will bring a lot of harmony to the organization when it comes to data lake implementations. Also, they influence change in processes and project lifecycle because they do have that visibility into three different teams, groups of teams: data architecture, CFO, and line of business. Let's take a look at accuracy. Data has to be accurate and trusted. In order to produce accurate financial numbers, always work backward. Manage and define your critical data of the organization. Manage and define your reference data. Define a canonical model and always work backward from that model. In AWS, we always work backward from our customers' needs. When we want to design a new service or make enhancement to our existing service, we always ask ourselves what our customer wants. And then we work backward from that vision. Do the same thing for data lake. Let your CFO or chief risk officer give you a canonical model and identify what they want, and then work backward from that. Also, manage quality of your data by use of integration, confirmation logic, removal of duplication or conflicting values. This is basically MDM practice, master data management. Let's look at a use case. Let's go back to our risk data lake. In this risk data lake, let's say that our CFO comes and tells us that they want to drive a total customer exposure across the enterprise. In that model, in the logical model, they like to have a customer identifier that never changes. They like to have a product exposure balance. They would like to have a product original balance and charge-off status. And they do not want duplicated customers, and they do not want to have several attributes keeping the balances. They want one of each, but they want the number to be trusted and certified. They also give us their reference data. They like the customers to be grouped in different types, and they give us the values for those types. They also give us the product types and classification as it pertains to their needs and how they want to call them. They also can give us list of charge-off codes. On the source systems, each line of business should provide a customer identifier, and they should provide exposure balance, original balance, and charge-off status. If they do not have those fields available in their source systems, they should provide all the fields that would drive those values. Of course, they have to provide the logic behind it also. They also should provide us mapping instruction. First of all, for all the reference data, they have to map their customer types, product types, and charge-off codes to what the canonical model and risk logical model requires. So they have to provide all those mapping instructions. Also, they have to provide all the deduping logics across products and customers. That's when data architecture, once these two sets of requirements are clarified, data architecture gets involved, and they start the master data management activities that can range from providing mapping logics within silver layer all the way to data exception handling logics, or identifying rapidly changing reference data from slowly changing reference data. All those items and their requirements help them to drive if they want to use a third-party master data management tool, or they like to have an in-house created one or a hybrid model. They are the ones that decide about finalized architecture. Let's look at where each part goes. So total customer exposure logical model goes to the gold. Reference data is part of the gold. Source system data extracts go to bronze. Mapping instruction goes to data architecture, and data architecture designs and architects a master data management or integration logic, ETL logic kind of processes that they deploy on silver. Let's look at the ownerships. Who owns which parts? Definitely CFO and Chief Risk Officer. They are the owner of that risk model. They also, reference data usually is being governed by CDO office or data governance office, but it can belong to CFO also. Data architecture definitely is in charge of the integration logic. Source systems, the owners are business owners, and the mapping instruction are owned by line of business data stewards. Let's look at quality. Data quality reporting can be categorized to two main categories. They can be operational. Examples are wrong products are categorized in wrong buckets within the source systems, or customers are assigned a wrong type within a source system, or critical data elements are gaps within the source system, so they have null values because the source system just doesn't have those. Integration quality reporting is when attributes to drive a new value might have missing values, or a major change in source system might trigger a major shift in the end result financial numbers. And that happens at the integration layer. So let's take a look at those. So we talked about integration data quality reports and operational data quality reports. Operational data quality reports are being done against bronze. Integration data quality reports are done against silver and gold. Operational data quality reports belong to line of business data stewards. They are the owners, and they are the ones who have to mitigate that. Integration data quality reports goes to the owner of the gold, which is CFO data stewards. Also, they have to work closely with line of business data steward to mitigate them, because the mapping logic came from line of business data stewards. Data governance plays a very big role here because they usually coordinate the quality reporting mitigations. Also, as part of enterprise-wide status report, they can bring visibility to a status of data quality. Let's look at data lineage. While we were all trying to implement a complex data lineage solution throughout the several past years, it kind of feels that the outcome and objective of data lineage got lost. Data lineage started because of two high-level categories. On the operations side, it was very hard to figure out if we change a source system, what would be the downstream impact? If we don't get a source system's SLA, and there is a notification for that, what that transpired to, and what is going to happen to the downstream, and what would be the downstream impact. Those are operational like data lineage requirements. On the audit, we got questions like, how do you know your data is correct? Or where did your data come from? While trying to implement data lineage tools, we kind of lost track of this objective. As a result, this is what we got. A very complex, either on the visualization part or on the information. Large amount of information that is very hard to navigate through. What we really wanted was to answer simple questions. If you have a loan exposure report, where did this data come from? That's all we wanted to ask and get an answer for. And what we really needed was somebody tells us, oh, you want loan exposure. So two source systems, one of them is origination application, one of them is servicing application, provides us with two files. These are the name of the files, they go to bronze. Then the loan file and the balance file and the customer file from bronze, they go to silver and they create two Parquet files. Creation of two Parquet files shows that the both files pass the data file validation and SLA. So they were good on that end. And then they went through integration logic on the silver and they created a loan exposure within gold. Production of reports like that are very, very powerful within a data lake. It will brings that harmony that you are trying to achieve between the data, the reports, consumers, lineage, quality. Very important to have. I like to take you through a reference architecture of if you want to build your own architecture using serverless technology on AWS and make it in a way that it's self-registered data lineage. So it doesn't need a lot of back and forth from data governance and CFO office or the gold or bronze business owners to drive it. And it would work as a decoupled architecture. Of course, that doesn't mean that I am disregarding data lineage tools. There are amazing third-party data lineage tools. This is just a reference architecture to show that an architecture has to take into consideration separation of rules and also take advantage of decoupled components. So in this case, the CFO likes to have a data lineage built for data gold zone, and that we do it with an API call. So CFO and business owners come and they give us the requirements. The requirement is that for every file that moves through lifecycle and different stages of data lake, they like to have a source, destination, and zone registered within a database so they can go run reports against it. In this case, we use Glue. And what we do is each Glue starts self-registering its source and destination and zone within that API call. The requirement from CFO can include extra information, like they might want to ask for timestamp or other information. And the Lambda function in here works as a very decoupled microservice that registers everything that they want within an RDS. And all these Glue jobs, just on an async basis, they can call the Lineage API and self-register their own lineage. Let's look at the example. This is a very simple piece of code that you can add to any ETL job. In this case, we do build all of our lineage requirements that was sent to us from our CDO. It has a job name, it has the source zone name, it has the source file name, source destination name, and a run date. And a simple async invocation of Lambda will register that information within our RDS table. So think about how you can leverage AWS Cloud's capabilities when it comes to serverless and decoupled architecture to build easy to use and simple to maintain components for your data quality and data lineage. The same kind of architecture can apply to data quality reporting. With that being said, this is the end of this presentation. Thank you very much for attending the presentation, and I hope you liked it and have a very good day.